Good evening, children. Good evening.
Good evening, ma'am.
Yeah, good
Good
evening. I've
evening.
shared my screen. Good evening. I've shared my screen. Is it visible? Yes. All right. I'll give you time to work, children. We'll discuss a set of questions, and at the end of that, I'll give you time to complete the notes in the class. All right. So first, we'll discuss. So here in triangle ABC, if triangle ABC is isosceles with AB equal to AC, and we have a circle. We have a circle with center O and radius R. That's how you read this. Circle with center O and radius R. Not C, not coordinates of C. It's not 0 and R are the coordinates of C, not that, okay? This is circle C with center O and radius R. Okay, so I mark this center O. Okay, and radius R. Is the incircle of the triangle ABC touching BC at F. Prove that F bisects BC. So we'll first understand the diagram. Yeah, we have a triangle ABC. Triangle ABC is isosceles with AB equal to AC. Okay. We see the incircle. Because we have the incircle, it also means that the sides of the triangle are tangential to the circle. The three sides of the triangle are tangential. The three sides of the triangle act as tangents to the circle. Okay. So the side AB is a tangent at D. The side BC is a tangent at F, and the side AC is a tangent at E. We also say D, E, and F are the points of contact. The point where the tangent touches the circle is the point of contact. So D, E, and F are the points of contact. Right? The three sides of the triangle are tangential to the circle. So the external points are A, B, and C. D, E, and F are the points on the circle. The points outside the circle are A, B, and C. So from A, we have two tangent segments, AD and AE. And we know that tangents from an external point of the circle are equal. So AD is equal to AE. We also have B, an external point. Tangents from the external point B to the circle are equal. So BD is equal to BF. Similarly, C is an external point. CE is equal to CF. So we have these results. Now we need to prove that F bisects BC. F bisects BC. That means BF is equal to FC. That's what we'll have to prove. Okay. All right. Now let's start with what is given. AB is equal to AC, right? This is given to us, correct? AB is equal to AC. Let's start with this. AB is equal to AC. Now you can write AB as what? AB is AD plus DB, correct? AB is AD plus DB. And what is AC? AE plus EC. Simple, no? Yeah. Now what is now is AD equal to AE? See here, AD is equal to AE, right? So can I cancel that on both the sides? Yes, I can cancel. So now we are left with what? DB is equal to EC. Okay. But DB is equal to BF. So let me write BF is equal to EC. EC is nothing but CF. CF. So now what's the result? BF is equal to CF. See here, BF is equal to CF. That means F bisects BC. Let's do it again. We start like this. Write what is given. AB is equal to AC is given. Okay. Now AB can be written as AD plus DB equal to AC can be written as AE plus EC. Now after this, we know that AD is equal to AE. Okay, so cancel it out. Now we have DB and EC. What is DB equal to? BF. DB is equal to BF equal to EC. EC is equal to CF. Like this, we get this result, BF is equal to CF, which means F is the midpoint of BC or F bisects BC. All right. So this is the first one. I told you I'll give you time to work this, children. Next. So in this figure, again, you see a triangle in circle. You need to prove that the sum of these three segments is equal to the sum of these three segments is equal to half the perimeter of triangle ABC. The triangle has three sides, but we can see six segments. No, we can see AR, BR, BP, CP, AQ, and CQ. Triangle, three sides. But we have six segments here, six line segments we can see. AR, BR, BP, CP, CQ, AQ. These six line segments are what you see here. You need to show that the sum of these three segments is equal to the sum of these three segments is equal to half the perimeter of triangle ABC. And a very simple proof. Yeah. So now you know the results, right? AR is equal to AQ, BR is equal to BP, and CP is equal to CQ. Tangents from an external point of the circle are equal, right? Okay. Now add these results. Add these three results. AR, let me write it neatly. I just want to erase it actually. AR is equal to AQ. Tangents from the external point A are equal. BR is equal to, okay, let me just tell you like this. It will be more easy. 1 minute. Let me just write out whatever we see here, children. Write out whatever you see here, okay? That'll be easy. You don't have to change the order later again. So let me write AR, let me write BP, and let me write CQ because I'm going to add the results. Is equal to, is equal to, is equal to. Okay. AR, BP, CQ, AR, BP, CQ. Now let's fill it. AR is equal to AQ. BP is equal to BR. CQ is equal to CP. Now add these results. Okay. So when you add, you get AR plus BP plus CQ is equal to AQ plus BR plus CP. So we proved this part. We proved the first part. See this one. That we proved this one. AR plus BP plus CQ. AR plus BP plus CQ is equal to AQ plus BR plus CP. AQ plus BR plus CP. Okay, so we proved that. Now we have to prove that these two are equal to half the perimeter of triangle ABC. Okay, you can, I just, because sometimes simple things are difficult, you know, so you can also write this, children, first. So you can also write AQ, BR, and CP equal to, correct? AQ, BR, CP, and then put an equal sign. Okay, now AQ is equal to what? AR. BR is equal to BP, and CP is equal to CQ. You can also add like this. So when you add, you get AQ plus BR plus CP is equal to AR plus BP plus CQ. Simple. See this one, and then we have this one. AQ plus BR plus CP is equal to AR plus BP plus CQ. Okay, so the first part we proved. Now, we'll have to show that these two are equal to half the perimeter of triangle ABC. Online children, am I audible?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah, thank you. Now next okay, so you have to write, you have to start like this. Perimeter of triangle ABC is equal to, you should write this by yourself. Perimeter of triangle ABC is equal to okay. triangle ABC is equal to AB plus BC plus CA. Now, what is AB? Let me write here. Okay, what is AB equal to? AB is what? AR plus BR, correct? And what is BC equal to? BP plus CP. And what is CA equal to? AQ plus CQ. Okay. This is not tangents from an external point of the circle are equal. No, AB is made up of AR and BR. AB is equal to AR plus BR. BC is equal to BP plus CP. And AC is equal to AQ plus CQ. All right. Now, see, we have this result, right? Look at this result. So AR, BP, CQ. AR, BP, CQ. Collected. See here. AR, BP, CQ. Then here it is AQ, BR, CP. See here. AQ, AQ, BR, and CP. So we're just rearranging the line segments. Just rearranging. Okay, now let me say that these two are equal to X. Any letter, we'll just call it X. So what do you have here? This one is X and this one is X. C? Oh, by mistake, I will see. Oh, yeah, thank you. Yeah, CP, CP. CP. Okay. No? Yeah. Okay. So I just came back here and I've called these two expressions as X. So this can be replaced, no? AR, BP, CQ. See, AR, BP, CQ is equal to X. AQ, BR, CP is equal to X. AQ, BR, CP is X. Clear? So this is equal to 2X. What is 2X? Perimeter of, above we have perimeter of triangle ABC is equal to 2X. So X is equal to, it will become by 2, right? Perimeter of triangle ABC. See above, it's an equation. We started with an equation. Perimeter of triangle ABC is equal to AB plus BC plus CA. So this 2X result we have. No, what is this? Perimeter of triangle ABC is equal to 2X is equal to 2X. So X is equal to perimeter of triangle ABC divided by 2. Divided by 2 is nothing but half into. Multiplying by half. So let me write divided by 2 first. Divided by 2. So this is nothing but X is equal to half of perimeter of triangle ABC. That's it. Got it, children? Online children? Wasn't that simple?
Yes, ma'am.
Okay. Yes, ma'am. Okay, children. Yeah, that's about this one. Exactly what we discussed is what you see on the slide. Next one. So again, you understand this figure. We need to show that AB plus CQ is equal to AC plus BQ. So let's start with that. AB plus CQ. Let's start with that. AB plus CQ is equal to. Now AB can be written as AP plus BP plus CQ. Can you write CQ in a different way? What is CQ? CQ is equal to CR. Right? AB is equal to, correct? AB is equal to AP plus BP. And CQ can be written as CR. Now tell me what next. We need to get AC and BQ, children. So with BP, you can get BQ, right? See, we need to get AC and BQ. How will you get AC? You should have AR and CR. No, look at the other side. The other side is AC and BQ, AC plus BQ. So for AC, you should get what? You should get AR plus CR for AC. And then you should have BQ plus BQ. So how do you get AR and CR? So what is AP? AP is nothing but AR. And CR we already have here, plus CR. Plus BP is nothing but BQ. That's it. AC is AC plus BQ. Let me do it again. See it. AB plus CQ. Okay. Is equal to AB is AP plus BP. Okay. Plus CQ can be written as CR. Tangents from an external point of the circle are equal. Now, what should you get? You should get AC plus BQ. What is AC? AR plus CR. AR plus CR plus BQ. This result you should get. AR, CR, and BQ. CR is there, so don't disturb this. So you need to get AR and BQ. See, CR we have here. So we need to get AR and BQ. AR. AP is equal to AR. So we got AR plus. We need to get BQ. BP is equal to BQ. So we got BQ also. Plus CR. Now we have all the line segments. So AR plus CR plus BQ. AR plus CR is AC plus BQ. All right. Okay. So that's what you see here, children. See here? This working. Now I'm just checking if I worked it exactly the way I explained. Yes, I have. Is it a different thing? Okay. Now for the next part. Okay, you need to prove that area of triangle ABC is equal to half into R is the radius of the incircle. R is the radius of the incircle into perimeter of triangle ABC. You can remember this result. Will be helpful for MCQs. This is the relationship between any triangle, its area, perimeter, and in radius. This is the relationship between area of a triangle, perimeter of the triangle, and its in radius. In radius is the radius of the incircle. Okay, so area of the triangle is equal to half into in radius into perimeter of the triangle ABC. Area of triangle ABC is equal to, this is the relationship between area, perimeter, and in radius. Area of triangle ABC is equal to half into in radius into perimeter of triangle ABC. So if you're given these two, you can substitute in this equation and find R. So given any two, you can find the third one using this equation. Okay, now let's see how to prove it. So for that, you'll have to join OA, join OB, join OC. So we have to divide the whole triangle into three smaller triangles. We have to divide the whole triangle into three smaller triangles. Now we know that AB, BC, and AC, they are tangential to the circle. The three sides of the triangle are tangential to the circle. They act as tangents to the circle. So P, Q, and R are the points of contact. And we know that the radius through the point of contact and the tangent are perpendicular to each other. P is the point of contact, PO is the radius. P is the point of contact, PO is the radius. And tangent, 90 degrees, 90 degrees, 90 degrees. Right? Come again. What should you do? Join the in radius to the vertex A. Join the in circle. In center. Join the in center O to the vertex A. Join the in center to the vertex A in center to the vertex B, in center to the vertex C. Okay. Now you need to make sure that these three small triangles, which are the three small triangles? AOB, BOC, and AOC. You need to make sure that these three small triangles have an altitude so that you can use the formula half base into height to find their areas. So now for triangle AOB, when you regard AB as the base, OP is the altitude because OP is perpendicular to AB, radius perpendicular to tangent. In triangle BOC, if you regard BC as the base, OQ is the altitude because OQ is perpendicular to BC, radius perpendicular to tangent. Similarly, in triangle AOC, if you take AC as the base, OR is the corresponding altitude. OR is the corresponding altitude because OR is perpendicular to AC, radius perpendicular to tangent. Now, we're going to write this equation. Area of triangle AOB plus area of triangle BOC plus area of triangle AOC is equal to area of the whole triangle ABC. Area of triangle AOB plus area of triangle BOC plus area of triangle AOC is equal to area of the whole triangle ABC. Correct? So half into base is AB. Okay, base is AB into OP, which is radius, in radius, plus half into base BC into radius, because height is OQ, which is R, plus half into base AC into the altitude is OR, which is R, which is the in radius, is equal to, right, area of triangle ABC as it is, because we have that in the result. No, see here. See, we have area of triangle ABC in the result. So you don't have to do anything with that. Area of triangle ABC as it is. Area of triangle ABC. Is equal to area of triangle ABC. Now what's common? Half R is common. Half into R is common into AB plus BC plus AC is equal to area of triangle ABC. You can see here, between these three expressions, half into R is common. So take out half R common. So in the bracket, you will have AB plus BC plus AC is equal to area of triangle ABC. So half into R into, what is AB plus BC plus AC? Perimeter of triangle ABC. Perimeter of triangle ABC is equal to area of triangle ABC. So this is the relationship. This is the relationship between the in radius, perimeter, and area of a triangle. Very simple, but to remember, you need to practice, children. That's exactly what you have on this slide. You can see here. First, the constructions. Okay, so first the constructions. Join OA, OB, OC. Okay. And then you have to mention, no, OP is perpendicular to AB. All this you'll have to mention because radius is perpendicular to tangent. Then area of the triangle is equal to, area of the whole triangle is equal to sum of the areas of the three small triangles, and yeah, the rest you know. All right. R is the in radius, the radius of the in circle. Okay. So here in this figure, You need to prove that AD is equal to half the perimeter of triangle ABC. Okay. All right. Now, be careful. AB and AC are not tangents. AB and AC, they are not tangents. AD is a tangent at D and AE is a tangent at E. AB and AC are not tangents. You cannot write AB is equal to AC. Okay, the external point is A and AD is a tangent segment. AE is a tangent segment, both from the external point A. So they are equal. So you need to prove AD is equal to half into perimeter of triangle ABC. So you should start with perimeter of triangle ABC is equal to. So what is perimeter of triangle ABC? AB plus BC plus AC. Okay. Now AB plus BC can be written as BF plus FC plus AC. Because AB, nothing you can do. AB is AB. And AC is AC. BC can be written as BF plus FC. That's why I told you AB is not equal to AC. AB is not equal to AC. Right? Okay. Okay, AB is not equal to AC, children. Okay, AD is equal to AE. Okay. So I said start with, let me write again. I said perimeter of triangle ABC is equal to AB plus BC plus AC. Now AB is AB, AC is AC. BC can be written as BF plus FC. Now further, again AB is AB, AC is AC. Okay, but BF can be written as BD. Because B is an external point and BD is equal to BF. C is an external point. C is equal to CF. Okay, so BF can be written as BD and FC can be written as CE. FC can be written as CE. Now, what is AD? AB plus DB. What is what is AB plus BD? AD. And what is CE plus AC? CE plus AC, AE. But these two are equal. No, AD is equal to AE. So you can write it as AD plus AD. Because AE is AD. Right? So you get twice AD. So perimeter is equal to twice AD. So AD is equal to, it will become by 2. So half into perimeter of triangle ABC. All right? Okay, once again, quickly. So start with perimeter of triangle ABC equal to AB plus BC plus AC. AB is AB. BC can be written as BF plus FC plus AC. Now further, BF can be written as BD and FC can be written as CE. CF, no, CF is equal to CE plus AC. Now AB plus BD, AB plus BD is AD plus CE plus AC is AE. And we know that AD is equal to AE. AD is equal to AE, right? And in the result, what do you have? AD. So what we're going to do? AD plus AE is AD. So we have twice AD. So perimeter of triangle ABC is equal to twice AD. So AD is equal to half into 2 goes for division, or it is half on the other side. 2 by 1 becomes 1 by 2 on the other side. The fraction becomes its reciprocal on the other side. No, so 2 by 1, it will become 1 by 2 on the other side. So 2 by 1 becomes 1 by 2 on the other side into perimeter of triangle ABC. That's all. Okay. So I think it's the same thing here. Yeah. Yeah, this is similar, children. You can help yourself. So here it is, it's numerical. This one, you have to prove the result. Here we have to prove the result. Here, for MCQs, you'll have to remember this result, children. So in a figure like this tangent AD or AE is equal to half the perimeter of triangle ABC. Have this figure in your mind. In a case like this, AD and AE are two tangents from the external point A, right? So AD or AE will be equal to half the perimeter of triangle ABC. This result you should remember. So here you can see all right. So here, what do you see? AB, the length of AB, AC, and BC is given, and we should find AP. So we know that AP is equal to half the perimeter of triangle ABC. Okay. AP, not AB, no, AP, AQ. AP is equal to half perimeter of triangle ABC, or AQ is also equal to half perimeter of triangle ABC. So this is the result which we know is equal to half into, how do you find perimeter of triangle ABC? AB plus BC plus AC. So 5 plus 6 plus 4, 15. So 7.5. In the next one, AQ is given, and you'll have to find the perimeter of triangle ABC. Again, AQ is equal to half into perimeter of triangle ABC. Because this result holds good for AP and AQ, right? So AQ is 9. 9 is equal to half into perimeter. So perimeter is equal to 9 into 2, 18. Perimeter is equal to 9 into 2, 18. So remember this result. AP and AQ both are equal to half the perimeter of triangle ABC. So in the first one, perimeter is given. That is, the sides are given, so you can find the perimeter. Perimeter is given, and you have to find AP. In the second one, AQ is given, like AP, AQ is given, and you have to find the perimeter. Given perimeter, find AP, or given AQ, find perimeter. So both can be done using this relation. The relation is AP is equal to AQ is equal to half into perimeter of triangle ABC is the result. Is the result. That's it. So here, I've proved it again. That's all. Because depending on the marks, you can actually, if it is 1 mark, you can use the result directly. See, this is the answer. The answer is here. This is the answer to the question. Yeah, so the answer is here, children. The answer is here because you know it now. So this is the proof of what we saw here. exactly the same proof. All right. Okay. Yeah. Children, just give me a minute. I'll come back. Yeah. Thank you, children. Online children, use emoji. Raise your hand. Okay, so Aniruddhan, Swati, Tanishka, Niveda, Jayvarshini, Bhavishya, Pratish, and Leslie. Okay, thank you. All right. All right, children. So here in this one, yeah, so you can see the details given. It's also marked in the figure. We need to prove that R is equal to S minus C, where S is the semi-perimeter, children. S is the semi-perimeter. S is not marked anywhere, but S is the semi-perimeter. You can see small letter A, B, and C. Small letters A and B are the legs, are the lengths of the legs of the. Oh, it's a right triangle. I don't. It's a right triangle, children. I should have marked 90 here. Both the places I have to mark. Okay. Okay, it's a right triangle. All right. A and B are the legs, are the length of the legs of the right triangle, and C is the length of the hypotenuse. R is the in radius, and S is the semi-perimeter, which is A plus B plus C by 2. Heron's formula. We have seen semi-perimeter S in Heron's formula. S is equal to A plus B plus C by 2. Okay. So you need to show that R is equal to, that is the in radius is equal to, in radius is equal to semi-perimeter minus the hypotenuse. In radius is equal to semi-perimeter minus the hypotenuse. R is equal to S minus C. Okay. Again, very simple. See here. Now, we know that we can prove this quadrilateral to be a rectangle and then a square. Okay. You can prove that this quadrilateral is a rectangle. Okay. How? See, this is 90 degrees given. See, it's not marked in my figure, children. It's a mistake. I have to mark. I'll have to show that this is a right angle. It's a right triangle. So this is 90. It will be given to you. Now this is 90 because radius perpendicular to tangent. OF is a radius. BC is a tangent. So radius perpendicular to tangent. This also radius perpendicular to tangent. So 90 degrees. So now in this quadrilateral, 3 out of 4 angles are right angles. So the fourth angle also by angle sum property will be a right angle. So in this quadrilateral, all the 4 angles are right angles. So it's a rectangle. In a rectangle, all the corners are right angles, right? So it's a rectangle. And why is it a square? In a rectangle, when one pair of adjacent sides are equal, it's a square. In a rectangle, if one pair of adjacent sides are equal, it's a square. So you can see here adjacent sides OF is equal to OE. Why OF is equal to OE? Because radius of the incircle. You can also say adjacent sides CE equals CF. CE equals CF because they are tangents from the external point C to the circle. Any one you can mention. In a rectangle, if you show that one pair of adjacent sides are equal, then it's a square. It's a rectangle because every angle is a right angle. One right angle given to us. This is 90. This is 90 by the theorem radius perpendicular to tangent. This is also 90 radius perpendicular to tangent. By angle sum property, this is 90. So in this quadrilateral, every angle is a right angle, so it's a rectangle. And in the rectangle, one pair of adjacent sides. So you can mention CF is equal to CE because they're tangents from the external point C to the circle. Or you can say OF is equal to OE, radius of the incircle. So one pair of adjacent sides equal. So the rectangle is a square. Rectangle OFCE is a square. Now in a square, all sides are equal. So if this is R and this is R, this is also R. I've mentioned this in one of the earlier classes that C is not the radius. The length of C is equal to the radius of the circle. C cannot become the radius or CF cannot become the radius. The length of C and CF is equal to the radius of the circle. If the radius is 5, then C is 5 and CF is also 5. But they are not the radius of the circle. Okay. Now, so first you need to prove that this quadrilateral is a square. Now we have done that. Okay, we have done that. So how much is this? This is R. So what's the rest of it? B minus R. This is B minus R. 1 minute. See, the whole thing is B, no? So this one is R, correct? This one is R, correct? So, but the whole thing is B. So how much is this? B minus R, B minus R. Now this one is R. So how much is this one? A minus R, A minus R. Now if BF is A minus R, then BG is also A minus R. BG is also A minus R. Because BF is equal to BG. Tangents from the external point B to the circle are equal. If AE is equal to B minus R, then AG is also B minus R. AG is equal to AE. AE, AG, tangents from the same external point A to the circle, they're equal. Now, Okay, you can write like this. BG plus GA is equal to BA, right? The hypotenuse. The hypotenuse BA is equal to BG plus GA. The hypotenuse BA is equal to BG plus GA. Now BG is how much? A minus R. And what is GA? B minus R. Is equal to what is BA? It is C. That's all. We got it. So A plus B, bring this C to the side. So minus C is equal to minus R is minus 2R. So when you take it to the other side, plus 2R. Because in the result, we have R on one side and S and C on the other side. So we're trying to have R on one side. Minus R is minus 2R. So take it to the RHS. Then have those A, B, and C on the left-hand side. Now you need S. For S, you need A plus B plus C. So what we're going to do is A plus B. You want a plus C. There's no plus C, but you want plus C. So you add C and subtract C. Plus C minus C. So like you've done nothing, no change, right? So plus C minus C. And there's already that minus C, right? That. This minus C, right? That. You're adding C and subtracting C. All right. This minus C as it is equal to 2R. Now A plus B plus C, this one A plus B plus C is 2S. Because okay, where I stopped. Yeah, I was telling you S is equal to what? A plus B plus C by 2, right? So when you cross multiply, you get A plus B plus C is equal to 2S. A plus B plus C is equal to 2S, right? When you cross multiply. So what is A plus B plus C? 2S. And minus 2C. Minus 2C is equal to 2R. So 2, you can take out common and cancel on both sides. So you get S minus C is equal to R. And that's what we have to prove. R is equal to S minus C. All right? Yeah. The same thing I worked here. Okay. Children, just go through this proof. I'm just coming back. Give me some 3 minutes. I'll come back. So here we'll have to show that the same figure, not even similar, same figure. You'll have to show that R is equal to S minus C, which we just did. Also, R is equal to A plus B minus C by 2. So, same thing. So, see here, at this stage, that is at this stage, when you bring the 2 for division, okay, so here, okay, bring the 2 for division, you'll get R is equal to A plus B minus C by 2, correct? At this stage, bring 2 for division, so R is equal to A plus B minus C by 2. So, R is equal to A plus B minus C by 2, you can get it from this step itself. If you want to show that R is equal to S minus C, then you have to add and subtract C. Then you need to do that plus C and minus C. Plus C minus C is to get this result. R is equal to S minus C. So how do you, so I'm not explaining this proof again. It's similar to the earlier one. So these results, please remember in words. So in a right triangle, the in radius is equal to sum of the legs minus hypotenuse by 2. In a right triangle, I'll change the figures. This is 90 degrees. Okay, so in a right triangle, the in radius is equal to the sum of the legs minus hypotenuse divided by 2. A and B are the legs. C is the hypotenuse. Sum of the legs minus hypotenuse by 2. Or the in radius is equal to the semi-perimeter minus the hypotenuse. S, semi-perimeter minus hypotenuse, not perimeter, semi-perimeter minus hypotenuse. Okay, so whatever you think is easy for you, if you want to remember like this, fine. Otherwise, in words, in radius is equal to semi-perimeter minus hypotenuse, or in radius is equal to sum of the legs minus hypotenuse divided by 2. Sum of the legs minus hypotenuse divided by 2. Or in radius is equal to semi-perimeter minus hypotenuse. In a right triangle. See, when we use the words legs and hypotenuse, it's a right triangle. It's a right triangle. Yeah. So you can expect such questions in MCQs. So you see it's a right triangle, and you have to find the radius of the incircle. Radius of the incircle. So you know the formula, right? How do you find the in radius? It is A plus B minus C by 2. So 8 plus 6 minus hypotenuse you can find using Pythagoras theorem. So it's 10 by 2. So 14 minus 10 by 2, 4 by 2, which is 2. The in radius is 2. The radius of the in circle is 2. Or you can also use this formula. R is equal to semi-perimeter minus hypotenuse. So semi-perimeter will be 8 plus 6 plus 10. This is the perimeter divided by 2. So 24 by 2, 12 is the semi-perimeter. So 12 minus the hypotenuse 10. Okay, which is 2. This is not 6, children. The whole thing is 6. Not this one. I'll change this. The whole thing is 6, like from here to here. It's given in the question. This is 6 centimeters. This is 8 centimeters. Just a minute, children. Yeah. I just forgot what we were talking about. We finished this one, right? I am. No, I actually forgot what I was doing. Let me just do it again. So what's the formula? In radius is equal to sum of the legs. So you can find the hypotenuse using Pythagoras theorem, right? 10. So in radius is equal to A plus B, sum of the legs, minus C, minus hypotenuse divided by 2, which is 2. 14 minus 10, 4 by 2, 2. Or it is S minus C. What is S? Semi-perimeter, which is 8 plus 6 plus 10 divided by 2. 24 by 2, 12. So 12 minus hypotenuse, 10, 2. Okay. Okay, I've done it in a different way here. Yeah, so if you want to work out, like if you want to work and find, meaning without using the formula, if it is not for 1 mark, if it's not for 1 mark, okay, so if it's for 2 or 3 marks, then you need to derive these formulae, like whichever formula you're using, you need to derive them and then use it. Like here, if you're going to use if you're going to use R is equal to S minus C, then derive this formula and then substitute the values and find R. Or if you're going to use this formula, R is equal to A plus B minus C by 2, derive this formula and then use the formula to find the value of R. If this were, like 3 marks, you should know that. So when to derive and then use the formula. If it's MCQ, yeah, you can just use the formula straight away and pick the answer, the correct answer. Okay, so there I've worked in a different way. What's the other formula we learned actually? In general, in a triangle, area of triangle ABC is equal to half into radius into, we just learned, no? Area of triangle ABC is equal to half into in radius into perimeter of triangle ABC. You can also use this formula. You can also use this formula. Because here we have no in radius. Area of triangle ABC is equal to half into in radius into perimeter of triangle ABC. So what's the area of triangle ABC? Half base into height, half into 8 into 6, right? So 8 3 is 24 is equal to half into R, we don't know, into perimeter. What's the perimeter? 24. So don't think we'll always get 24, 24, meaning the same numbers on either sides. In this case, it's the same. Cancels, and you can see R is equal to 2. R is equal to 2. You can also use this formula. Area of triangle ABC is equal to half into in radius into perimeter of triangle ABC. Area you can find using the formula half base into height is equal to half into radius into perimeter. Sum of all the sides, 8 plus 6 plus 10. 10 we found using Pythagoras theorem, the hypotenuse. You can also do this. So behind that is the answer here, I'll just tell you how it's worked. So join O to C, O to A, O to B. So again, dividing the whole triangle into 3 smaller triangles, and then you know the equation. Area of triangle AOB plus area of triangle BOC plus area of triangle AOC is equal to area of triangle ABC. And for each of the triangles, you know the altitudes. You know the altitudes for each of the triangles. Radius perpendicular to tangent. So that method I've used here. Because it's already explained earlier, I don't want to repeat and bug you, so you know this. Half base and right, half base and right, half base and right. Substitute. And height everywhere is R. R. Yeah. Similar children. Yeah, right triangle, A circle, AB, BC given, so you can find AC, and you'll have to find the in radius. Many approaches now actually. So if it is for 3 marks, you'll have to derive that formula and then use it. Derive the formula and use it. If you want to use this formula, R is equal to S minus C, derive it and use it. If you want to use R is equal to A plus B minus C by 2, derive this and use it. If you want to use area is equal to half into in radius into perimeter, please derive this and use this. If you're like, no, I don't want to derive anything, I want to just do it directly, then this is the method. Join OA, join OB, join OC. Okay, so we're like, no, I just want a direct approach. I don't want to derive any formula and find the in radius. How do I otherwise find the in radius without deriving anything? Then you can do this. Divide the whole triangle into 3 smaller triangles and write area of the sum of the areas of the 3 small triangles is equal to the area of the whole triangle. Okay, I've done each sum in a different way, but you can do it in any method. You have many options for this. So if you don't want to derive any formula but work it directly, then join OA, OB, OC. All right, and then sum of the areas of the 3 small triangles is equal to area of the whole triangle. Do that and get the value of R. Or you can also do this. You can do that, or you can do this one. Prove that this one is a square. This is the other approach. Approach 1 is 1 second. 1 second, children. One minute, children. Yeah, thank you, children. So I was telling you about approach 1. You can join O to A, O to B, O to C, divide the whole triangle into 3 smaller triangles and frame this equation. Sum of the areas of the 3 small triangles is equal to the area of the whole triangle ABC. Using that, you can find the value of R. Or approach 2, prove that this quadrilateral is a square. Prove that this quadrilateral is a square. How? First prove it's a rectangle. And in the rectangle, adjacent sides are equal. One pair of adjacent sides are equal. So it's a square. All right. How do you prove it's a rectangle? This is 90 because it's a right triangle. Radius perpendicular to tangent. Radius perpendicular to tangent. This is the radius. See, this is the point of contact. P is the point of contact of the tangent BC with a circle. Q is the point of contact of the tangent AB with a circle. So through P, through the point of contact P, through the point of contact P, when you join that to the center of the circle, it's a radius. And this radius is perpendicular to the tangent. Q point of contact, QO radius. All right. Okay. So 90, 90. So this is 90 by the angle sum property. So this is a rectangle because every angle is a right angle. And in the rectangle, one pair of adjacent sides are equal. OQ is equal to OP. Or you can say BP is equal to BQ. Tangents from an external point of the circle are equal. So it's a square. So it's a square. Now, this is in radius, in radius. So this is also in radius, in radius. Value. The length of those line segments are equal to the in radius. Now, AB is how much? AB is 24. AB is 24. This one is 24. Okay. AB is 24. So AQ will be, what's AQ? 24 minus R. AQ will be, so AQ is what? AB minus BQ. So AB is 24 minus BQR. So this is AQ. If AQ is 24 minus R, then what is AR? 24 minus R. Because AQ is equal to AR, tangents from the same external point A to the circle. What's BC? What is PC? PC is BC minus BP. Okay, so BC is 10 minus R. So if PC or CP is 10 minus R, then CR is also 10 minus R. Now, AC is equal to how much? Hypotenuse by Pythagoras theorem, 26. But what is AC equal to? AR plus RC equal to 26. What is AR? 24 minus R plus and RC 10 minus R is equal to 26. So 34 minus 26 is equal to 2R. So 4 and 4, 8 is equal to 2R. R is equal to 4. R is equal to 4. Without writing, no, like I'll just mark in the diagram. So it's, easier to remember. So this one is a square. This is R. This is R. The whole thing is 10. So this is going to be 10 minus R. So if this is 10 minus R, this one is 10 minus R. CP is equal to CR. This is R, but the whole thing is 24. AB is 24. So AQ will be 24 minus R. So if AQ is 24 minus R, AR is also 24 minus R. But we know AC by Pythagoras theorem is 26. So there we have the equation 24 minus R plus 10 minus R is equal to 26. So R is equal to, as we got 8 by 2, which is 4. So you can use this approach. So here we didn't use any formula. We're using the theorem. Tangents from an external point of the circle are equal. We're using the theorem. So you can do this. We didn't use any formula here. We proved that OQBP is a square. And then we use the theorem, tangents from an external point of the circle are equal. So this method, or as I told you, join OA, OB, OC, the triangle. Triangle plus triangle plus triangle is equal to area of the whole triangle. So by now you should have understood that because I've worked the sum in this way, it's not that you should work it in this way only. Okay, a question like this, you can use any approach. This is slightly different. Just a minute, children. Yeah. Yeah, thank you once again, children. Let me continue. So here again, find the radius of the inner circle. Okay. You have to join, prove that this is square, R, 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 R. This is 30. BD is 30. So BE is 30. BE is 30. CD is 7. So CF is 7. CF is 7. Now connect the sides using Pythagoras theorem. Connect the sides using Pythagoras theorem. AB square plus AC square is equal to BC square. What is AB? 30 plus R. 30 plus R the whole square. Plus what is AC? R plus 7 or 7 plus R, okay, the whole square is equal to BC. 30 plus 7, 37, 37 square. Okay, so you have to join OE and OF, prove that this quadrilateral is a square. Okay. And so all the sides are equal. So AF is R and AE is R. You get it? BD is 30, so BE is 30. CF is CD is 7, so CF is 7. Connect the sides using Pythagoras theorem. Yeah, we'll take up this in the next class, children. Oh, that's it. Yeah. So we have half an hour more for this class. Online children, I've shared the images on WhatsApp. I want all of you to complete the notes now and share the images with me on WhatsApp. All of you. Anirudhan, I can see Anirudhan, Bhavishya, Blessy, Jayvarshini, Niveda, Pratish, Swati, and Tanishka. I've shared the images on WhatsApp, right? All of you. If it goes beyond 9 o'clock, finish it and then leave the meeting. I want all of you to complete the notes before you leave the call. Yeah, please start working. Let's stop the recording.